Greetings, hello, welcome. So in this video we are going to look at how to plot some trigonometric functions, and we'll start with plotting the following trig functions. Let's say y is equals to sine 2x, and let's say g of x is equals to tan of x, and all these graph will be over the domain from 0 to 360 degrees. So let's go ahead and plot them, shall we? The same axis. So we'll start with that one over there. Okay, so let's plot y is equals to sine 2x. Before I do that, let me explain what the domain means. The domain means that the graph that we'll plot should start from 0 and then end at 360. We cannot exceed 360. If we exceed 360, then we are no longer in the given domain. So all our x values should be less than 360 degrees, and well, they should start from 0. Okay, hope that makes sense. With that said, let's go ahead and plot this. Let's plot y is equals to sine 2x. Before that, let's find the period. Formula for the period is 2 pi over b, where b represents this number here, the coefficient of x in the trig function. So period will be 2 pi over 2. In this case, we just left with pi. So this is the period in reds. We're working in degrees, so we can just rewrite this formula. 2 pi is the same thing as 360 divided by b. That's b is 2, so divided by 2 gives us 180 degrees. So this pi seconds, 180. Wow, this is not the same thing as that. Okay. Alright, so pi is 180. Okay, cool. So what the period tells us is that the graph repeats itself after 180. Every after 180 degrees, the graph will repeat itself. Every after pi, the graph will repeat itself. So this is the period in degrees. Okay. So let's go ahead and plot our graph. I think we'll do justice to find our intervals. Just to spread out the period evenly. So we'll go ahead and say, okay, 180 divided by 4 gives me 45. 45 degrees, alright. Cool. So at this point, let's create ourselves a table. Okay, this is where we'll have our x values. In here we'll have y. Let's say our y values. Sine 2x. Okay. Start from 0. 45 plus 45, that's 90. 90 plus 45, that is 135. Okay, 135 plus 45, 180. Plus 45, that gives me 225. 270. 315. And then 360. Alright. Sine 2 times 0. Okay, sine of 0 is the same thing as sine of 0. It's 0. Sine 45. Sine 2 times 45 is the same thing as sine 90. So that's 1. 1 sine 90 sine of 0 sine 135 minus 1 sine 180 0 225 is 1 0 minus 1 0. Now what? Let's just go ahead and add to this table. Let's add tan x. Let's just plot all these functions on the same graph. Okay, tan of 0, that is tan x of 0, that is 0. Tan 45, that is okay. And tan 135 minus 1. Tan 180, that is 0. Tan 225, it's see 1. Tan 270, that's well, calculator says math error, so that's infinity. 315, that is minus 1. 360, that is 0. Okay, cool. Now you can just go ahead and plot this. 0. We can already see from here that the highest point is 1 and the lowest point is minus 1. So just by looking at sine at y is equals to sine 2x, we can see that our amplitude is 1. So if there was negative there, the amplitude will still be 1 because we only consider the absolute value, which is 1 in this case. So amplitude is 1 and the lowest point would be negative 1. $45, 90, 135, 180, and then 225, 270, 315, and then 360 final. Okay, now what I want to do is just indicate just these lines to help guide me, the grid lines. Okay, so I'm gonna plot what is this sine 2x. So looking at my table tells me that sine 2x at 0, let me use a different color, tells me that it's sine 2x at 0, sine 2x is 0, and at 45 it's 1. It's 45 it's 1, and at 90 it's 0, and at 135 it's negative 1, at 180 it's 0, and at 225 it's 1, at 270 it's 0, 315 it must go down to 1, 360 0. So to plot my graph to look like that. So my graph will have a shape like that. Wow. So yeah. Okay, so the graph will look like that. So this is the graph of f of x, or let's say y is equals to sine 2x. Now let's plot at 0 and x is 0. At 90, well, at 45 it's 1. 1. At 90 it's infinity. So with tan x, it's not similar to sine and cosine. Well, then it's not similar to the two graphs, to sine and cosine graphs, in the sense that it has vertical asymptotes. So at every point where you have the sign of infinity, simply means that tan graph approaches these vertical asymptotes but never really touches them. That's why they go all the way to infinity. And also we have 1 at 270. These are asymptotes. Okay. Pardon me. Okay, so let's go ahead and plot the graph, shall we? So the graph will start from 0 and to approach the asymptote never really touching it. Okay, the mouse is acting up. Alright, there we go, now it's responding. Because it goes all the way to positive infinity, and then it comes right from negative infinity, and then at 135 135 I can do better than this, I think. So graph would look so it will go all the way to negative infinity. Yeah, so the graph will look something like this. Okay. Yeah, it's not easy drawing this graph, but yeah, graph will look something like that. Remember, our domain ends at 360, so we can't draw the other portion here which goes all the way up, uh, because we'll now be extending our domain beyond 360. If we can observe, we do see that the tan function repeats itself every after 180 degrees. So the period of a tan graph is 180. So this is x, tan x. So yeah, cool. Just test that out from 90 to 270. That should be 180, because 270 minus 90, that gives you 180. So yeah, cool. So yeah, that's how you plot sine 2x and tan 2x intercept. Okay, we for okay, on the graph we could indicate the intercept. Okay, we for sine 2x, we get a different color for this. Sine 2x, we see that it intersects the x-axis at 0 0. It begins, that's where it starts, and then at 90 and well, yeah, 90 0 and 180 y0. At that point, 270 y0, 360 y0. And it has a turning point, maximum turning point at 45 1, and a minimum turning point at 135. Amplitude is -1. It also has maximum turning point again at 225. Amplitude is 1, and another minimum turning point at 315. Well, where y is -1. Okay. Interesting. That's what we call this point. Looking at this graph, looking at the graph, we can see that that's what we call this point. Let's call this point at, at this point, and this one, and this one, and that point over there, that one over there, this one over there, that one over there, that one over there. So at every point where g of x intersects f of x, the graphs are equal. In other words, the y values are equal. So what I'm saying is this: f of x minus g of x is equals to 0 when these two graphs are equal. This can just rewrite this equation as f of x is equals to g of x. So if f of x is at 0, at point 0, simple, the point where f of x intersects g of x will have f of x is 0, g of x is also 0. So 0 minus 0 gives us 0. At point 0, when x is, and then also at 45, 0, g of x is point B, gives us 0. You can call that point A. And then also at 45, we can call that point B. F of x is 1, g of x is 1. So 1 minus 1 is, relationship is not satisfied. There is well, is the same as f of x, which is minus 1. So minus 1 minus minus 1, the same thing as minus 1 plus 1, which is 0. So this point also the relationship is satisfied. The same applies at point, let's call that one point D, and at that point 225, 1 minus 1 is 0. At F and 270, well, there is no intersection there. T 0 minus 0, it's 0. E, point E, 225, 1 minus 1 is 0. At F and 270, well, there is no intersection there. So at 315, call that point F, the relationship is satisfied. So at the following points that I've just indicated there, which is the following points, this relationship is satisfied. At A 0 0, B, which is 45 1, C 135 minus 1, and D 180 0, and E at point 225 1, and finally F at 315 minus 1. So that relationship is satisfied. Okay. Let's look at points where f of x is greater than g of x. So looking at the graph, right there at this point from 0 to 45, we see that the graph of sine 2x is greater than the graph of g of x, and at point 0 and at 0 and at 45 they are equal, where they that so from 0 to 45 degrees and from 180 to what is this, to 225, the relationship is satisfied. So we can just get these as our points where that relationship is satisfied. Okay. Okay, last but not least, let's look at something else. Let's look at how to identify amplitudes and periods of random given trig functions. This is the last portion of the video. So let's say you're given function y is equals to minus 2 sine 1 over 3x, and then you are required to find the amplitude. In this case, the amplitude is always the number in front of the trig of the function, In this case, we get positive of that number. In other words, the absolute value of that number. So absolute value of minus 2 is always a positive value. Of any number is always a positive value. So 2 is our amplitude. We just get the absolute value of that number. So 2 is our amplitude in this case. So let's say we're given, what about the period? Well, the period in this case would be 2 pi over 1 over 3. So 2 pi divided by b, that's the formula. And b is always this number, coefficient of x. So 2 pi over 1 over 3 give you the period, which is 2 pi times 3 over 1, 6 pi. Let's look at another one. Say we're given y is equal to sine 5x. Then let's find the period. Well, just write down the formula, 2 pi over b. So 2 pi, b is what? 5. Another one. So 5 there. 2 pi over 5 seconds 3 cos 1 over 4 x, and we're required to find the period. Well, just do the same thing, right? Down the formula, and that's our b. So 2 pi over 1 over 4 equals to 2 pi times 4 over 1 at pi as my period. And my amplitude is 3. Okay, so finally let's look at say y is equals to say 5 over 8 sine minus 8 pi over 3x. Question is find the period. The period will be 2 pi over b. What is b? B is all this right there. Okay, so 2 pi divided by minus 8 pi over 3 gives me 2 pi times 3 over 8 pi divided by negative, divided by those pi's fall away. 1, that's 4, so we have 4 seconds. Would be our period. Okay, the last question, last one. Question probably be would say you are given amplitude. So you are given the amplitude as 4 and given period as 3 pi. Then you asked find the the question would say write down the equation of the sine function given the above data. A sine bx. What is our b? Well, our b, you can find it from 2 pi over b. So b is equals to 2 pi over period, which is equals to 2 pi over 3 pi. Pi falls away, so we have 2/3 as our b. Therefore, y is equals to 4 sine 2/3 x as our function. Alright, thank you for your patience. Thank you for watching. God bless you.